Yeah, hi students. How are you? I hope you are fine. All right. Uh, Today we are going to start with calculus. Calculus. When we talk of calculus, we are talking about differentiation and integration and its related, items. If I should put it that way. So today we are going to start with the calculus. But before starting with the calculus, normally at a certain point in time, we will be needing the limits. Okay, we shall be needing the limit. As a result of that, we shall go through some, fundamental limits, and then from there, then we enter into the general aspect of the differentiation, and then the integration, and so on and so forth. Let me encourage you that you have to subscribe to the Calendar Man TV. The Calendar Man TV. When you subscribe, make sure that you click on the notification button. There are lots that are be coming your way. Now, this calculus that we are starting, we will be starting from here, moving from junior high, whatever it is, up to the tertiary level. And so, if you are able to listen to this calculus, of course, you have the general background. If you are doing economics at the university, the economics student, you also need the calculus. Those who are doing what we call quantitative techniques and others, this business quantitative methods, you need the calculus in so many ways. So that is how it is. So with that, on this platform, normally we deal with straight away with the calculations. We normally solve questions. This is a problem-solving platform, problem-solving television that will definitely be helping you. Let me say that in the course of our presentation, we shall pause and be talking about the Forever Construction and Consultancies Limited. It's a limited that is actually that deals with the lands and so on and so forth. So I'll be giving you your numbers, their numbers, so that if you're interested in land, you can purchase land from them. Those of you outside the country and others. So I'll be in the course of time. I will be doing their live presenter mention together with the Ashin Senior High School, the best senior high school located in Medina. So in the course of time, we shall talk about that. Without wasting time, we are talking about the whole is what? Calculus. Calculus. And under the calculus, we shall be talking about differentiation. But before then, let's talk about limits. I hope you understand limit. If I have, let's say, x raised to power 3, okay, and we are asked to evaluate limits, let me put it, x3, where we see that x maps to 2. What do you think is going to be your answer? The thing is x raised to power 3, and they say that, so when x approaches 2 or x approaches 2, what are we going to have? We are going to have the x itself is what? Is 2. Then to the power 3, that will give you what? 8. I'm repeating. X raised to power 3. And you say the limit as x approaches 2. So it means whenever you see x, you put what? 2 there. So it becomes what? 2 raised to power 3 is equal to what? 8. Similarly, if I have, let's say, limit x raised to power, let's say, 4, then I do this. Where x approaches 3, what happens? The limit x approaches 3. What are you going to have? Sorry. It's going to be what? It's going to be 3, okay, raised to power 4. And that will be what? I think 81. I hope you're getting the point. So you'll be solving, and we shall try as much as possible to limit projection. You will not be projecting so much. You will just be solving the problems straight away, and then you'll be getting it. So if I have a limit, so I've just captured the question and I put it then, limit x, where I say x approaches what? 0, then what are you going to have? If I evaluate it, it's going to be what? It's going to be 0, because the x itself is 0. Now, let me see another, or let me check another one. Okay, I'm having another one here. limit 3x, where x approaches 2. What happens? What happens? It's going to be 3, then where x is, this is x. So the 3 is there. The x will come here, the x is what? 2. In place of x, we put 2 there. And that will subsequently give you what? 6. I guess I've made my point. Yes. So that is basically how we'll be going about it, and on and on and on and on. So I'm still on what? Limits. We are talking about calculus, and I'm still on limits. So I've just captured the various, aspects here. Let's look at another one. Limits x plus 2, where x approaches 5. What do you think is going to happen? It means that this is the expression we are evaluating. So here becomes, x is what? X itself is 5, so we have x is 5 plus 2, and that will be what? 7. I don't think this is a difficulty. Now let's look at another interesting one. Another one is this. Limit, I hope you understand the point I'm making here. Limit x plus 2. That is, wherever you see x, put 5 there, that's the meaning. So we put 5 here, and then we do what? We add the 2. The 2 is constant. When we do that, that's what we are getting. I'm just reminding you again that you have to subscribe to Calendar Man TV. As I've already informed you, Forever Construction and Consultancies Limited, okay, it's a company that actually deals with land, litigation-free land. So if you want to purchase a land, if you want to purchase a special, they are building houses as well. If you want to do that, then it's their lands, it's a fast developing area. That is where they are located, with roads demarcated and others. So if you want land at a Dodowa, Oyibi, and several places in Sawom and others, Dodowa, Utubleku and others, please, you can call their number, the Forever Construction and Consultancies Limited. Just call their number, and then you'll get it very free. It will help you. So their number is 050 151 8355. Forever Construction, 050 151 8355, or 055 48 92 143. I'm repeating, 055 48 92 143. So if you purchase the land from them, they will help you in the documentation and others. So just call the number that I've given to you, and you'll never regret it at all. That is for your information. So if you are interested, that is the Forever Construction and Consultancies Limited. Try as much as possible to secure land from them, and you will never regret it. Now, as we proceed, let's see, or let us get more update about the limits. Okay. So, because if you are not able to understand the limit at a certain point in time, we shall be in trouble. We are treating calculus. Calculus, that will be leading to what? That is the differentiation and integration. Let's look at another one. I have x squared plus 1, where we say that the limit x maps to what? To 3. What happens? In this case, what are we going to have? The x is what? This x, they said, so that means whenever you see x, you put 3 there. So it becomes what? 3 squared plus 1. And that will be equal to what? 9 plus 1, making 10. I guess I've made my point. Yes. Now, let me put another. We are working more examples. Another one is limit or x squared minus 2, where x approaches 4. What happens? X squared minus 2, where x approaches 4. Whenever you see x, you put 4 there, so it becomes what? 4 squared minus what? 2, and that would be what? 16 minus 2, giving you 14. Okay, 16 minus 2 will be giving you what do you call 14. Okay, now We can also extend our area to the quadratics, where we have limits x squared plus 6x minus 1, where we see that x approaches 3. So what happens? It means that whenever you see x, you put 3 there. So it becomes, in place of this one, so it becomes what? 3 squared plus 6. Here is another x, 3 minus 1. Okay, so it becomes what? 9. Remember that 3 squared is not 3 times 2, it is 3 times 3. Then this is what? 18 minus 1. So here, I think here will be 27 minus 1, which is equal to what? 26. I'm repeating. We are having this quadratic expression, and we are saying that x approaches what? Or x is equal to x mapping onto 3. That means whenever you see x, put 3 there. It's as simple as ABC and easy as 1, 2, 3. Exactly. This and many more and many more. Let's look at another one. Okay. I'm having, you have to find the limit of x plus 1, then x squared minus 5, where this is limit x approaches 2. So in the same way, what are we going to do? In place of this is x, so here is what? 2 plus 1 in that bracket. Then this is another x, which is what? 2 squared minus 5. So in the nutshell, I'm going to get 3 here, and then here is what? 4 minus 5. So it is 3 times what? Negative 1, which is equal to what? Negative 3. Okay, that is how it goes on and on and on and on and on. Now, you have to continue. Okay, you have to continue. So let's see the way forward. We are talking about limits under the calculus. Okay, we are talking about what? Limit under the calculus. So we want to look at rational function. If I say rational functions, I'm talking about a function in a special form. So we are talking about limits of what? Rational functions. So I think we have to, let me see if I'll be able to get a typical example. For example, if I have limits, I've already told you that we are going to limit projection. We are not going to limit so much. We are not going to project so much. That's why I'm writing directly the question here so that we solve together, then we get it right. Okay, minus 1 all over x plus 1. Okay, this is a rational function, and you say that x approaches what? 2. Now, here you have to be very, very, very careful, because if you decide to put the x straight into this expression, you'll be in trouble. Because when we are dealing with the algebraic expressions, we said that this particular expression, it is difference of what? 2 squares. So over here, we are going to have x plus 1, if you could remember. If not, then go back to the algebraic expression on Calendar Man TV. Go and subscribe and look at it. You understand it. So x minus 1, x plus 1. Sorry. X plus 1, x minus 1. All over x plus 1. If you factorize the top expression, that's what you are going to have. So over here, this one cancels this. So in effect, we are going to get limit x approaches what? X minus 1. Where this approaches 2. So we are going to have what? 2 minus 1, and that will be equal to what? 1. Is that okay? It's going to be 1. But basically, that is what is actually, occurring. There's another one where we say we have x squared minus 4, and the limit is x approaching, what is it? X approaching 0. So if x is approaching 0, and we have this all over x minus 2, then this is purely also a rational function. So we have to factorize this. The top is what? x, okay, x squared minus what? 2 squared, all over x minus 2. So in effect, the top will be what? Difference of 2, top will be what? X plus 2, x minus 2, all over x minus 2. So x minus 2 cancels x minus 2. So we have limit x approaches 0 will be what? X plus 2. Okay? So that will be what? And x is approaching 0, so 0 plus 2, and that will give you 2. I'm repeating. This is an expression. And then you are factorizing what? This and that. Okay? So by virtue of that, this, you break this one first and you cancel. So that is what you are having. Okay? If you make any attempt of actually putting 0, 0 here, I don't know, but basically this is the right way you have to go. So let us see another one. There is a quadratic expression here. When we said you have limits x approaches 2, and what is it? We have x squared minus 7x plus 10 all over x squared minus 4. It could be recalled that when we were dealing with algebraic expressions, we explained how to factorize quadratic expressions. So if you factorize the quadratic expression, then what are we going to get from here? We're going to have x minus 5x plus 2, okay? What about the down? The down is what? X plus 2, x minus 2. So in the nutshell, this one will cancel this, okay? So we are left with what? Limit x approaches to, top is what? X minus 5, down is what? X minus 2. So if you have to put it inside, what is x? X is 2, so we have what? 2 minus 5, okay? All over 2 minus 2. And of course, when this one happens, then it means we are going to have negative 2 over 0, which is undefined. Anytime you are working something and it is that number divided by 0, then of course it is what? It is undefined. So that is that, because it will be 2 minus 0. So this one will be undefined. Note that if it were to be, and here it's even negative 3, but it is still undefined. Anytime you divide a number by 0, the expression is what? It is undefined. Okay. Now, we have to move on to different level. That is, we want to talk about limit up to what? To infinity. Okay. Limit to what? To infinity. So when we are talking about limit to infinity, let's try as much as possible to get it. I hope this one will be getting a little bit wet for me, so that I'll be using it as such. So limit to infinity. We are still talking about calculus. Okay, calculus. That is. So we talk about limit to what? To infinity. Okay, infinity is more or less endless, something of that sort. So, as I've already told you, and this time when we are working, we move straight to a typical problem. So we want to evaluate. We want to evaluate. Let me write the typical limit. X 1 to infinity. 6x squared plus 1 all over 4x squared minus 1. Now, this is what? Limit to infinity. When you see this, it is an infinity sign. It's like h which has turned the other way around. Here, what is going to happen is that you look at the highest, the x value, which is the exponent, the highest exponent. So here the highest exponent for the x is what? Is 2. So what we are going to do is that we are also going to divide through by that is the x squared. So here I'm going to have 6x squared over x squared plus 1 over x squared all over 4x squared over x squared minus 1 over x squared. I'm repeating. Look at the highest exponent here and then divide it through by all of them. Is that okay? So this is x squared. So divide through x squared by x squared over this, x squared over everything. So you could see that here, what are we going to have? We are going to have 6, okay, plus 1 over x squared all over, here will also be what? 4 minus 1 over x squared. I'm repeating it here. I said we have 6 plus 1 over x squared all over 4 minus 1 over x squared. Now, after doing this cancellation, you will see that there is x squared, still x squared, squared. Whenever you see x still remaining in it, it goes straight to 0. So here we are going to have what? 6 over 4, which is I think 2, what is it? If you are having, it's 1.5, okay, or 1.5 is your result. Limit to infinity. So I'm trying to get more of that and then be giving it to you. Now, let's look at another limit to infinity, another typical example here. You say evaluate limit to infinity, x maps onto this. And we have x raised to power 4, okay, x raised to power 4 plus x squared all over x raised to power, okay, x raised to power, okay, 3 plus x raised to power, let's say, okay, 5. I've readjusted my question a little bit so that we will look at the difference and see how best this thing will actually be handled. Okay. So now let's see how this one is going to be. I've changed the question a little bit. So over here, the question is, what is the highest exponent here? The highest exponent here is what? The highest exponent here is going to be what? It's 5. So I'm going to have x raised to power 4 over x5 plus x squared over x5 all over x3 over what? x5 plus x5 over x5. Okay, this is it. So if you have to work it out, here, by principle of indices, we are going to have what? 1 over x for this first part. Then plus, here is going to be what? Here is going to be 1 over x cubed, okay? Divided by x3 over x5 is what? 1 over x squared plus 1. So, because when you cancel, so you could see that finally x are remaining. So here, this one will go to 0 because there's still x. Here goes to 0, here goes to what? 0. So it will be 0 plus 0 at the top there. So finally it's going to be 0 over 1, which is equal to what? 0. Limit to infinity is what we are actually talking about. Let me, for us to be able to understand, I'm trying to give you, more examples under the limit to infinity. So let me quote another one and see how we'll be able to actually get it. We have, okay, x raised to power 7. I say limit x to what? To infinity. X raised to power 7 plus x raised to power 5 all over 3 plus x raised to power 5 to power 7. we are having something like this. And you want to evaluate this limit to what? To infinity. The question is, what is the highest exponent? That's what you have to take into consideration. What is the highest exponent in this regard? What is the highest exponent? What is the highest exponent? What is the highest exponent in this regard? Highest exponent in this regard. The highest exponent in this regard. Okay, the highest exponent is 7. So I'm having what? So it's going to what? X raised to the power 7 over x raised to the power 7. Then we come here. Plus x raised to the power 5 over x raised to the power 7. All over 3 over x raised to the power 7 plus 5x7 over x raised to the power 7. What did I say? I'm saying that you should be able to identify the highest exponent so that you use that exponent together with the x at the base to divide through all of them. So let's start from here. Here, what happens? When you cancel, here is what? 1. Then here becomes what? Plus 1 over x squared. Sorry. All over 3 over x7 plus 5. This one cancel this. Okay. So in effect, what are we getting? Here, there's still x here, so here goes to 0. Here also goes to what? 0. So we are left with what? 1 over 5. 1 over 5. I guess I've made my point, and it's very, very okay for you. It's very, very okay for you. No. It's very, very okay for you. So you can now proceed, move to the next, aspect of it. So now, right now we're speaking about limit to infinity. Now let's look at a last example and then limit to infinity. Then we can proceed to different levels. I'm having another one here, which is what? 7x all over x minus 4. So you want to evaluate this limit x to what? Infinity. So what happens? So here, what's the highest exponent? It is still x. So I'm having 7x over x all over x minus 4 over x. This one will cancel this. So the top here will be what? 7. What about the down here? Here is 1 minus 4 over x. This one goes to 0. So we are having 7 over 1, which is equal to what? 7. Alright? It is equal to 7 when we work it out. This and many more. So I think we have to move to different level of it. So right now, we want to start a differentiation now. Now that we've got our limit to infinity, we want to start differentiation. And the differentiation will be going by the ordinary way. After that, then we move to differentiation from first principles. Please try as much as possible to subscribe to the Calendarman TV. Okay? And we are being supported by Forever Construction and Consultancies Limited. That you have to buy your land from. And the land, I've already mentioned their numbers, litigation-free land. Okay? We have land at Dodowa, Amainia, and then several, including in Sawam and others. Just try and then get them. When you get the land, they will help you in the documentation. And you can call Forever Construction and Consultancies Limited. If you are outside Ghana and you are watching me, those of you who are watching me, I'm saying that if you want to buy a land, or if you want to buy even, especially with the bird homes as well, call this number 050 151 8355. I'm repeating 050 151 8355 or 055 48 92 143. I'm repeating 055 48 92 143. Forever Construction and Consultancy Limited. Buy your land there, and it will help you. Now, right now, you want to talk about differentiation, okay? So differentiation, okay? Differentiation. if I have y is equal to axn, and I want to differentiate it, I'm using this, I'll later use numbers, okay? Then I'm saying that the y, the x, that means I'm differentiating y with respect to what? To x. Is going to be, you move this n here, be n, then ax n minus 1. Now, anytime you are teaching and you use these letters, it tends to confuse a lot of students. So I'm going to use numbers. Is that okay? I'm going to use numbers. Let me remind you that Ashin Senior High School is also supporting, and in the course of time, you also hear about them. Now, differentiation. So, for example, if I have y is equal to 4x7, then dy dx, this 7 will come. This 7 is a bird. It will come here and become a human being. We will have to lead the team. So it is 7 times 4x. You write the 7 again, then this and subtract 1 from it, because one of the birds have flown to become a human being in front here. So here is what? Here is what? 28x raised to power what? 6. That is our dy dx. Let me give you another example. If I have y is equal to, let's say, 4x 3, then dy dx is equal to 3 times 4x. Okay, you bring the 3 again. You see that this expression is still here. Just that the 3 has come, this time you subtract 1 from it. So it becomes what? 12x squared. That is your dy dx. Dy dx is equal to 12x squared. Okay. Now, let's see another one. If I have y is equal to 5x to the power 4 plus 8x plus 2. You want to differentiate this. How do you go about it? You have to differentiate them one after the other. So dy dx is equal to what? 4 times 5x4 minus 1. Okay? Plus, note that this is 1. Here's what? 1 times 8x, 1 minus 1, then plus 0. Note, anytime you are differentiating a constant, a number which is not having any variable attached to it, that number goes to 0. Okay, so in differentiating this, here we are going to get what? We are going to get 20x3, okay, plus 8. Note that here is 8x0 because this one, 0 minus 0. And any number raised to power 0 is equal to 1. So it is like 8 times 1. So it becomes 20x cubed plus 8. And this one has gone to 0. I'm repeating. Why has this one gone to 0? Because we have the 2 here, this 2 here. Anytime you differentiating, let's say 18, 27, whatever it's whether negative or positive, it goes to 0. If it is a constant, it's not having any variable attached to it. Is that okay? Sure. So we have to be solving more. Now let's see another example. If I have y is equal to, let me pick another one. Y is equal to 1 over x, let's say 6. By principle of indices, okay, if I have this, I can write it as y is equal to x raised to the power negative 6, like this. That this one has to go up. Is that okay? That's how it is. So here, I'm going to have dy dx is equal to what? Why is going to happen? Because this is, here becomes negative 6. So what are we going to have? We are going to move this expression. It becomes negative 6x minus 6. This time, also minus 1 from this. And that gives you what? Negative 6x 7. I can decide to send it down by saying negative 6 over x raised to the power 7. When the x moves down, it becomes what? A positive 7. Is that okay? That is how it is. Now, I want us to look at another typical Example, still under differentiation, ordinary differentiation. We are treating calculus, and under the calculus, we are talking about differentiation, okay, in an ordinary way, differentiation. So the topic is calculus, and we are on differentiation. Let's look at another one. If I have y is equal to 7x squared plus 8, then dy dx is equal, you bring this to about 2 times 7x 2 minus 1 plus 0. This one is 0. So you're having what? 14x to the power 1, which is equal to 14x. Are you okay? That's how it is. Now, subscribe to Calendar Man TV. We'll be teaching more topics. Okay? We'll be teaching, so tell your friends, whether you're in the technical school or whatever, wherever, university or not, you're going to treat a lot over there. So subscribe to Calendar Man TV and enjoy it. Trigonometry, plane geometry and others. All of them will be dealt with accordingly. So don't waste time at all. Make sure that when you subscribe, you press the notification button. That's the bell. Okay, just to give you the expected notification anytime I launch in that. Now let's look at another one. If I have y is equal to 1 over 3x4 plus let's say root x. Now, how are you going to differentiate this? Let us put it in a refined way first. So I'm having y is equal to 1 over 3 x to the power negative 4, right? This one has to go up, plus x to the power half. I want you to understand this point before we proceed. I'm saying that this one, the x has moved up, but the 3 didn't go. The 3 is constant. The x has moved up and becomes what? The x4 has moved up, become negative 4. But this one is half. So if you have to treat them, then I'm going to have negative 4 times what? 1 over 3 x negative 4 minus 1. I'm repeating. The 3, it is only this one that moves up and becomes negative over there. The 3 still remains. So here, the negative 4 is multiplying this times this. Then here is x negative 4 exponent minus 1. Okay? Plus, here we have what? Half x 1 over 2 minus 1. Okay? So what are we getting? We are getting what? Negative 4 over 3 x what? Negative 5. Okay. Plus 1 over 2 x negative half. This one is a little bit challenging, but you have to try and then follow it as such. So you should know how to, this is a principle of English, you should know how to go about it. I'm repeating, this one moves up, and this one also we've transformed it into this form. Okay, so now, here this negative 4 is here. 1 over 3 comes, this negative 4 comes again, this time minus 1. And negative 4, negative 1 gives you negative 5. Negative 7, negative 8 will give you what? Negative, what is it negative 15 or whatever it is. Negative 2, negative 3 gives you negative 5, and so on and so forth. It's not positive, exactly. Now, once again, here also, what happens? I brought this half in front here, then I maintained it, then I subtracted 1. If I'm having half and I subtract 1 from it, what do you have? I have negative half, and that's what I've written. So in the nutshell, dx. From here going, it's differentiation. Here I was trying to transform it to understand mathematics. But if only you follow us, you follow with a series of topics that we are going to treat. At a certain point in time, there will be a time we will be moving to the mathematics. At a certain point in time, thermodynamics and all those areas will also be coming in. So we have a lot that we'll be learning from this TV, that's the Calendar Man TV. So now we are talking about higher order what? derivatives, okay, or higher derivatives. If I say derivative, I'm talking about differentiation, exactly. So higher order or higher derivatives. If I have y is equal to, let's say, 2x4 plus 6x3 plus s squared minus 2. And then we want to differentiate this 3 times. The first derivative will be what? dy dx is equal to, this time we'll be moving fast a little bit. This 4 will multiply, it becomes what? 4 times what? 2x3, right? I'm repeating. Because we subtract 1 from here. Because with our previous understanding, I believe now you understand why we have subtracted it, why the 4 has come here. Or if not, let me take my time so that people will not blame me for that. So I'm having 4, okay, 2x, 4 minus 1, okay, plus 3, 6x, 3 minus 1, plus 2x, 2 minus 1, plus 0. Is that okay? So over here, what are we going to have? We are going to have 8x cubed plus 18x squared plus 2x. Got this one to the power 1. This is dy dx. Then we have the squared y over the s squared, which is the second differential. That will be what? You multiply 3 by this one, you get 24s squared, okay, plus you multiply this 18 to what? 36x, okay, then plus 2. So then I can say the cubed y over the s cubed is going to be what? It's going to be, you multiply this again to be what? 48, that's this one comes here, 48x plus 36, okay. I can continue to do it again. I can say the 4 to the power 4 over the x to the power 4. That is the fourth derivative. It will be what? 48 plus 0, which is equal to what? 48. I hope you understand the point. That is, you can be actually, first one is what? Dy dx. Second one is what? You differentiate this again, and you get this. Is that okay? You get this, and I think that time will be notified when it is 1 hour. Time will be notified. So in that order, that we will be moving. Okay. So the squared x over the x squared, and we have that. The cube y over the s cube is that. You can continue to actually do this on series of. It's just like, you know, we have the velocity and the time and others. If you differentiate, I think distance, you are going to get what? The s and the t. You are going to get the velocity, and if you differentiate velocity, you get acceleration in that order, just as it happens in the kinematics and other aspects, other disciplines. Okay, so we are moving on and on and on. I want us to look at a typical example, then we move as such. Now, here I don't want to waste too much time here, but we want to look at what you call before we move to the product rules and others, we call something differentiation from first principles. Differentiation from first principles. Differentiation from first principles. But you need some basis before the differentiation from first principles come in. Okay. Now, let's take this. You call something the binomial expansion, and under the binomial expansion, there are certain bases that you have to know. For example, students normally make some mistake. If you give him, let's say, x plus y squared, what is the answer? The funny answers that they give is surprising. About 70% of the students will just say that it is x squared plus y squared, which is not true. They will just say x squared plus y squared. It is wrong. Exactly. If we expand this, there's something that we are going to have. So before we expand this, we are going to use what we call the Pascal triangle. Okay? We are going to use what we call the Pascal triangle. And what is the Pascal triangle? Why are we doing this? Because we are going to use this in the differentiation from what? From the first principle. We have to get this basis. Otherwise, if you are not able to understand this one, then of course we cannot get that one clear. Exactly. Possibly, I don't know, but in the course of time we'll be able to know. When it is 1 hour, we move to different areas. I will definitely be signal about that. When it is almost 5 minutes to that time, you know, because we'll be moving on and on and on. Exactly. So over here, look at what I'm going to do. I want to expand this, okay, using the Pascal triangle. So look at what I'm going to do. I'm going to build this triangle, 1 here, 1 here, 1 here. Please watch. Now, I'll add this to this. It will be at 2. Take note of this so that when you reach the Pascal triangle, what do you call it? The polynomial, these expansions, binomial, this thing will not suffer. So I write 1 and the n here, 1 and the n here. Are you following? I first wrote 1 here, 1 here. Then I added 1 and 1 here. Let me go back. This is how we start it. This part, this is what? 2. Then I write 1 and the n, 1 and the n. We are starting again. This part, this is what? 3. This part, this is also what? 3. I write 1 n here, 1 n here. This part, this is what? 4. This part, this is what? 6. This part, this is what? You write it in the middle. Look at where I'm writing it. 4. I write 1 n here, 1 n here. I'm building a triangle. This part, this is what? 5. This part, this is what? 10. This part, this is what? 10. This part, this is what? 5. I write 1 n, 1 n. Look at the way I'm building it. Let me do it last one. I can do it for a lot of, but this part, this is what? 6. 15. 20. 15. 6. 1, 1. So carefully look at the way this triangle looks like. So that's what we are going to use to do our expansion. Now, always, what we are going to expand, if the power here is 2, then we are going to take the one that has 3 numbers. That is 1, 2, 3. So this is square. Because of the square, I'm going to use 1, 2, 3. If the power here is 4 and 3, we are going to use the one bearing 4 coefficients. Exactly. Now, so look at what I'm going to do. In fact, we are going to pick this. So look at what I'm going to do. So I will start. I have what? X plus y squared is equal to the first number here is what? 1. Then I pick the first number, x. Then I bring the square. I'm picking. I pick the 1 here. Then I bring x, x2, y0. So y0 is still 1. That's why we don't normally write it. So like x2, y0 plus next coefficient is what? Is 2 x1, y1. So then plus what? X, y what? Y2, 1, y2. I'm repeating. Look at what I'm doing. These are the coefficients, exactly. So since the power here is 2, I'm using the one bearing 3 coefficients. So I go to 1, this one. Then I pick the first term, which is what? X. Then I bring the square. So x to y0. So the x, as the x increases, x decreases, y increases. So x to y0, where y0 is the same as 1. In the number is y0 is 1. Then I pick the second coefficient here, which is what? 2. So it becomes what? 2x1, y1. That is, as x decreases, y increases. Then plus 1, y what? Y2, x0, where x0 is equal to 1. Exactly. So finally, I'm going to get, in the subsequent expansions, I'll be moving faster a little bit, so pay attention. What am I doing? What I'm doing, it is leading to differentiation from first principles. But if you don't have this basis, you shall suffer. That's why I'm doing that. So here is what? S squared plus 2xy plus what? Y squared. This is the expansion. Okay. So let's pick another example. If I have what do you call? Okay. If I have x plus y, then the power is 3. What is going to happen? Since the power is 3, we are going to pick this coefficient. So it's going to be 1 x3 y0, where y0, don't write it, plus this time, because this part is 4, I'm going to use this one, plus what? 3x2 y1, so that it should be in such a way that when you add the power, it should give you the 3, this and this 3. So plus another what? 3 what? x1 y2, then plus y3. So I'm having x cubed plus 3x squared y plus 3x y squared plus y cubed. I hope you've got a point. I hope you've gotten the point. Okay, so sure. Now that we are getting this, okay, with this understanding, let me quickly look at this one, because very soon we shall be starting the differentiation from what? From first principle. So if I have a minus b to the power, let's say 5, what happens? Here, when there's minus, then they just alternate. Note that. So here, because of the 5, I'm going to use the one parentheses. 1, 2, 3, 4, 5, 6. So I'm having a5. Now this one, they alternate. This is positive. Okay, a5, b0 minus something, that is what? You are using this. 5a4 b1 plus, look at the way it is going. Plus what? Plus 10 a3 b2 plus another 10 a what? Another 10 a2 b3 plus in that order until you finish. So here is minus, so it will be plus and minus until you finish. So anytime there's negative sign between this one, it is plus and minus. Is that okay? So we will be breaking a bit, and then we'll be moving to the next aspect. But when I come back, then we are going to start the differentiation from first principle. Now that this one has actually been established. So before then, let's see this one quickly. If I have, let's say, x minus h, what happens to the power 3? This one, the power is 3, so it becomes what? It becomes x cubed. I've told you. Minus, because of the 3, we are going to use this one. Minus what? Minus 3x squared h1. Plus, because of the minus, they are alternating. Plus what? Plus 3. Because of this 3. Then the x reduces. X h2. Okay. Then plus what? No, minus h3. So that's what you. So x cubed minus 3x squared h plus 3x h squared minus h cubed. That's how the expansion is going to be. So when I come back, we are moving straight to differentiation from first principles. Then after that, we'll be moving to the partial derivative and so on and so forth. The what you call the function of functions, the product rules and others. We're moving to the limit and others. So thank you very much. We shall be coming to the tutorial 2 very soon. So that's so after you watch this one, try and watch the tutorial 2. They will be in that series. Thank you very much.